Hi, everybody, and welcome back to Precalculus. This once again is Mr. Gallagher, and this is our last Precalculus math lesson for this school year. And I know it hasn't been easy with distance learning and getting all of this done. So thank you so much for sticking with us and getting some key knowledge in here and going over some key concepts as we finish up the school year. Today we're going to focus on part 2 of our logarithm review. So last time with logarithms we talked about going from logarithms to exponents and vice versa, and then also looked at some logarithmic graphs. Today we're going to look at some of the properties of logarithmic expressions, and specifically we're going to look at the product property, the quotient property, and our power property. So let me go over these and give you some quick examples of each one. So this first one, which is the product property, it says that if I have log base b, or of any number, of x times y, I can separate that into two logarithms. And based on the way logarithms work, it's not going to be log base b of x times log base b of y. It's going to be log base b of x plus log base b of y. Let me give you an example here. So example number 1, if I say I have log base 4 of 3x, well, I can break that apart into two separate logarithms, log base 4 of 3 and log base 4 of x. And those are going to be added together because, that's a horribly looking 3, let me fix that, because the 3 times x, and if you actually worked these out, if you had actual numbers that you could convert from logarithmic to numerical value or exponential values, you would see that this property does hold true. Because these are exponents, you can't just split them apart multiplication to multiplication based on some of the properties and laws of exponents that you've learned in the past. So that's the product property. The quotient property says if I have log base b of some number divided by another number, well, then that's going to be broken up into two logarithms that are subtracted from one another. Let me give you a sample for that one. So let's say I've got log base 5 of 3/7. Well, I can split that up into log base 5 of 3 and log base 5 of 7, but there's going to be a subtraction in between. So terms that are found in the denominator are going to have a negative log when I split them apart. So this is going to be log base 3 of 5 minus log base 5, log base 5 of 3 minus log base 5 of 7. And then finally, we have the power property. And that says if I have some logarithm of log base b of x to some power p, I can actually take that power, the exponent p, and move it to the front of the logarithm in a multiplication format. So that means that this is going to now be p log base b of x. So for example, if I have log base 10 of 4 to the third power, that is going to be the same as 3 times log base 10 of 4. And you could try these with simple examples numerically that work. And if you look at both expressions, these do come out to be equivalent values, and these properties do prove to be true. So that's the basic properties: the product property, the quotient property, and the power property. Let's take a minute and look at a couple of examples that that are similar to what you're going to see on a worksheet, that are a little more complex than some of those examples. Let's say I've got log base 2 of, and it's going to be this whole expression, the 5th root of 3 times x plus 2 to the third power, and that's going to be all over x minus 1. And I want to expand this expression here into multiple logarithms. So what am I going to do? Well, this is going to involve the product property, quotient property, and the power property all together. So first of all, I've got this fraction, and we know that log base 2 of some fraction, I can break that up into two logarithms that are subtracted from each other. So let's do that first. This is going to be log base 2 of the numerator, which is the 5th root of 3 times x plus 2 to the third, and then I'm going to have minus log base 2 of the entire quantity x minus 1. That's using my quotient property, right? And I split that up. That log base 2 of x minus 1 is pretty much simplified as it is. But now we're going to look at the left hand, the left part, the first expression there, see if we can simplify that anymore. Well, that fifth root, isn't that really log base 2 of 3 times x plus 2 to the third raised to the 1/5, right? And if that's raised to the 1/5, then what can I do? I can bring, using the power rule, I can bring that 1/5 to the front. So that's going to be the same as 1/5 log base 2 of 3 times x plus 2 to the third power, right? Okay. Again, minus log base 2 of x minus 1. Now what can I do? Well, I've got this 3 and I've got this x plus 2 to the third. That one, in fact, I really don't even need these parentheses here, right? Log base 2 of all of this. The one common mistake might be to take that 3 and move it to the front. But think about it. Does that, this 3 right here, this exponent, does that exponent apply to the x plus 2 or to the 3 or both? It only applies to the x plus 2. It's not 3 times x plus 2 quantity cubed, right? That cubed only applies to the x plus 2. So I can't bring the 3 in front of my log because it's not a 3 that applies to the whole log. But I can split up because these two terms here, the 3 and the x plus 2 to the third power, are multiplied together. I can split those up into two logarithms that are added together. So I can say 1/5 log base 2 of 3 plus 1/5 log base 2 of x plus 2 to the third power. And look what I just did there. I took the 3 and the x plus 2 cubed and I split them up into two terms. Notice the 1/5 applied to both of the terms still, right? Now what can I do? Well, this isn't going to change. This one's pretty simplified. 1/5 log base 2 of 3 plus, now can I move this 3 to the front? Yes. And when I move it to the front, that's going to become 3/5 log base 2 of x plus 2, and then minus log base 2 of x minus 1. And that's my full expansion of this problem. Couple of things to point out. Some people might want to split that up into log base 2 of x plus log base 2 of 2. And you can't do that because those are added. Remember, you can only expand when things are multiplied or divided. You can't expand it when there's already a plus or minus inside of that term. So this cannot be expanded any more than it already has been. So that's my final answer right here. All right, let's try another one. What about if I work in reverse? Let's look at example number 2. And this is going to be a condense. I want to condense the following. So let's look at this expression. What if I have 3 log base 4 of x minus 5 log base 4 of y plus 2 log base 4 of z. Now, before I can do any condensing, one thing you have to check is, do all of these logs have the same base? And they do. If they didn't have the same base, I could not condense them unless I changed the base up and things like that first. Notice here on the examples when I gave you the properties, when I expanded or when I expanded from one log to another, all the logs had the same base, right? So here, if I'm going to do an opposite of condensing, I have to make sure all logs have the same base. They do. So they all have a base of 4, so I can condense these. Well, first, let's go backwards. Let's deal with the exponents first. That 3 that's in the front, can I move that forward? And then this 2 that's in the front, can I move that forward? And let's do that. So this is going to be log base 4 of x cubed minus, also the 5, I should have mentioned that, log base 4 of y to the 5th, right? And then finally plus 2 log, whoops, I'm moving the 2, plus log base 4 of z squared. So I've used the power rule to bring all those numbers up to the front. Now, can I condense all of these? I can, because these are logarithms that are added or subtracted, so I can put these into one form. Now be careful here, log base 4, and this is going to be a fraction, and the question is going to be what's on top and what's on bottom. Remember, the terms that go into the numerator, terms that go into the denominator are the terms that have been subtracted within the entire expression. Well, the only one that's subtracted is this term right here, that log base 4 of y to the 5th. So that's actually what's going to go on the bottom, this y to the 5th. And then up top, what am I going to have? Well, I'm going to have x to the 3rd, and I'm going to have z squared. And this right here is my final answer. So look at what I did to condense these three terms, the log base 4 of x to the 3rd minus log base 4 of x to the 5th plus log base 4 of x squared. When I combine them into one single log base 4, the x to the 3rd and the z squared go on top, and the y to the 5th go on the bottom. Why? Because that's a minus and that's a plus. So the plus means multiplied times the x cubed, and the minus means I'm going to be dividing by y to the 5th once they're all in one logarithm. And that's it. So there's an example of expanding a logarithmic expression into multiple logs, and an example of taking multiple logarithmic expressions and condensing them down into one. And that'll be it. You've got a worksheet on eCampus. Please make sure that you take that worksheet and turn that in under the assignment section. And don't forget to check in on the discussion boards as well. Thank you very much, and take care.